Welcome back to Integrated Geometry 9 with a continuation of Fieldbook lesson examples for building blocks unit. And the lesson is about lines. And here we've got an awesome example of a really typical kind of problem that we like to do in algebra. And it is also related to a kind of problem that we like to do in geometry, which we will do in constructions. So we have here, we are given 3 points, E -3, 0, F 5, -4, Q 4, 2. And we want to find the coordinates of a point P such that the line PQ is parallel to the line EF. Well, first off, some things that we know. One is from our parallel slope property, PQ being parallel to EF if and only if the slopes are equal. Or they are vertical lines. Which remember means the lines have no slope. So that's the definition that we're going to use. We want to say something about the slopes. So let's look for the slope of the line that we do have, which is the line EF. We have 2 points on that. So we are going to find the slope of EF. So then I go to my slope formula. And I know that my slope formula tells me that my slope M for EF is given by the difference of Y values over the difference of X values from these 2 points that I have here. So I'm going to designate E as point number 1. So the X1 is -3, the Y1 is 0. And I'm going to designate F as my point 2. So my X2 is a 5 and my Y2 is a -4. So I can now simplify in black. -4 minus 0 is -4. 5 minus a -3 is an 8 because it's 5 plus 3. And this simplifies to 1/2. So that was our second step. So now my third step, I want the slope of PQ to also equal -1/2. That's what I want to have happen. All right. So I'm going to I don't know what P is, but I'm going to let P be some point X and some point Y. This is a classic math thing here. 2 classic math things I'm using. The royal we, the mathematical royal we, instead of saying I want, I say we want. Or we say we want. And the other thing is I'm telling the reader here is to let P be some generic X and Y. So now the slope of PQ would be written as And here, I want to actually, just to make my math a little bit easier, I want my Q to be the X1, and I want my P to be my X2, and I'll show you why. It's because, again, in my numerator, I want the difference of my Y's over the difference in my X's. So here I'm going to say Y minus 2 is going to be over X minus 4. And ultimately, I want this to be equal to -1 over 2. So, okay, that's what I want. So how could this be so? Well, there are actually multiple correct answers. And that's because I really have a single equation with 2 variables in it. A really easy way to go about this is to say, if X minus 4 is equal to 2, that means that X is equal to 6. And if Y minus 2 is equal to -1, that means that Y is equal to 1. And so the point P being 6, 1 should work, because then 1 minus 2 is a -1, and 6 minus 4 is a +2. So we get that slope. But I could also say that X minus 4 is equal to a -1, and Y minus 2 is equal to, -2. X minus 4 is a -2, and Y minus 2 is equal to a +1. Because 1 divided by a -2 is still -1/2. And this top one would mean that X is equal to 2. And the bottom one would mean that Y is equal to 3. So the point P of 2, 3 would also work. And indeed, there's infinitely many possibilities for me with an X and a Y, because I need the ratio to simplify to be -1/2. I could have said here X minus 4 is equal to 20, and Y minus 2 is equal to -10, and get a different X and Y value, because -10 divided by 20 is still -1/2. So indeed, it's actually infinitely many that will work. So cool.